Okay, so I asked you to round these to the nearest 16th of an inch. So what we're doing with these is we're first turning them into fractions, but not how we would normally turn a decimal into a fraction. We're just turning it into a fraction as quickly as possible. So the 0.847, I'm just going to make it 0.847 over 1. Right now it's a fraction with a denominator of 1, but we want the denominator to be 16. So to change it, I'm going to multiply by 16. What I multiply the bottom or the denominator by, I must also multiply the numerator or the top by. So I have 16 on bottom. I have 0.847 times 16, 13.552. So what this is telling me is that this is between 13/16 and 14/16. Which one is it closer to? That's 0.5, so it's closer to the 14/16. So 14/16 is going to reduce to 7/8. So to the nearest 16th of an inch, that is 7/8 of an inch. Over here now. First of all, the 3, I'm going to ignore. That'll be part of my answer later. But for right now, it's not going to be part of my calculation. So I'm going to take the 0.968 and I'm going to make it a fraction by putting it over 1 again. Notice the decimal point is still in there at this point on both of these. Now again, we want the denominator to be 16. If we wanted it to be 32, we'd multiply by 32. Wanted it to be 8, we'd multiply by 8. We want it to be 16, so we're going to multiply by 16. So that's 16 there, 0.968 times 16 is 15.488. So that is telling us that it is between 15/16 and 16/16. Which one's it closer to? Slightly closer, it's 0.4, so it's slightly closer to the 15/16. So that's 3 and 15/16 inches. If that had been 15.5, it would have been closer to the 16/16, which meant it would have just been 4 whole inches. We added an inch to it. Over here, you guys talk me through this one. Pull off the 9, then what? 0.201 over 1, and then times 16 on 16, so 3.216, and then it's between 3/16 and 4/16. Which one's it closer to? 3/16. 9 and 3/16 of an inch. Any questions? Those make sense? We've done them once or twice before, but wanted to hit them one more time before we wrapped them up. Okay, so today, starting off our new material. Kind of a new twist on an old topic. If we had 5 plus a -7, how did we do that? Well, we used the number line. Here's 0. +5 goes that way. -7 goes the opposite direction. Is it longer or shorter? It's longer. So that tells us our answer is negative, and it's -2. It's the difference between 5 and 7. Well, what if this looked like this? Now what? Well, first of all, we need to decide, since one's negative and one's positive, we need to decide which one's longer. Which is going to be longer, 1/4 or 5/6? 5/6. So we're starting at 0 here. -1/4 goes this way. +5/6 goes the other way, and it's longer. So it's going to put us on the positive side. So our answer here is going to be positive. But since they're going opposite directions, it's going to be the difference between 1/4 and 5/6. So I'm going to have to do 5/6 minus 1/4. Common denominator will be 12. This is going to be 10 twelfths. This will be 3 twelfths. 10 minus 3 is 7 twelfths. This is going to be a positive 7 twelfths. It's the exact same process as we had with whole numbers, only it's a little bit more work because of the fractions. So what if I had 1/4 minus a negative 3/8? What do I do with subtraction? I turn it into adding the opposite. So this is going to become 1/4 plus, what's the opposite of negative 3/8? Positive 3/8. Remember, if we had something like 7 minus a negative 5, that became 7 plus a positive 5. Same concept here. 1/4 minus a negative 3/8 becomes 1/4 plus 3/8. So our common denominator is 8. This is 2/8. This stays 3/8. 2 and 3 make 5/8. Or if we were multiplying, like this, we can ignore the negatives and just multiply like we normally would. We can cross cancel even. The 2 and 4 can both be divided by 2 to give me 1 and 2. So now I have 1 times 3 is 3, 5 times 2 is 10, but it's a positive times a negative, that's a negative. Or a negative 2/3 divided by 3/8. Can I cross cancel the 3's? No, why not? Because right now it's division. But I'm going to change it into multiplication. It's going to be times 8/3. Now I could cross cancel because it's multiplication. Unfortunately, now there's nothing to cross cancel. 2 times 8 is 16. 3 times 3 is 9. 16/9 is 1 7/9. But it's a negative times a positive. That's going to be a negative 1 7/9. So our signs and our positives and negatives with our integers apply to our fractions as well. It's just a little bit more difficult to do the calculations because of the fractions. Any questions on those? Okay, so our next step, we're going to look at this again. What does that mean? 10 to the third power. It's an exponent, 10 to the third power. And if we were going to calculate it, it would be 10 times 10 times 10, which would multiply out to be 1,000. What would 10 to the 5th come out to be? Multiply out to be 100,000. How about 10 to the 2nd? 10 squared, 10 times 10 is 100. Or 10 to the 7th. Well, how was I able to calculate those out so quickly? Obviously, there's a pattern. Does anybody see what the pattern is? Sure. 10 to the power of 3, we end up with a 1 followed by 3 zeros. 10 to the power of 5, we have a 1 followed by 5 zeros. 10 to the power of 2, 2 zeros. 7, 7 zeros. What if it's 10 to the power of 0? Not 0. It's 1. If you want to look at the pattern, there'd be 0 zeros, right? But let's take a look at why that's 1. Let's get a better look at what that is. 10 to the power of 4 is 10,000. 10 to the power of 3 was 1,000. 10 to the power of 2 is 100. 10 to the power of 1, of course, is just 10. If we look at this and look for a pattern, our powers of 10, when the power reduces by 1, the answer over here is divided by 10. At each spot, this is divided by 10. This is divided by 10. So if I were to keep going here, 10 to the power of 0, what's 10 divided by 10? 1. Anything to the power of 0 has to be 1. Remember that. I could give you some really nasty problems. What's that have to equal? 1. It's the power of 0. Anything to the power of 0 is 1. Now, I wouldn't do that to you. I wouldn't do that to you either. You would have wasted a lot of your... Yeah. Let's keep going with this now. We know that anything to the power of 0 is 1, so 10 to the power of 0 is 1. What would 10 to the negative 1 be? Well, we'd have to divide by 10 again. 1 divided by 10 is 1/10. 10 to the negative 2 would be 1/100th. 10 to the negative 3, 1 over 1,000. Now we see a pattern developing here as well. A connection between those two. What is it? 10 to the negative third is just 1 over 10 to the positive third, or a reciprocal of 10 to the third. These right here are a very important pattern. We're going to come back to them a little later on. For right now, we're going to work with these powers, the 10 itself, the exponents. So 10 to the third we said was 10 times 10 times 10. What if we take that 10 to the third and multiply by 10 to the fifth? Now we could multiply this out and get a number, but what I want is an answer that is, in terms of an exponent, 10 to some power. Well, 10 to the third is 3 tens multiplied together. 10 to the fifth is 5 tens multiplied together. If I multiply those together, how many tens do I have? 8. 10 to the 8th. If I had 10 to the 7th times 10 to the 12th, what am I going to get?
It would be 10 times 10 times
10
10
to the 19th. Do you see a pattern developing here? Yeah, when I'm multiplying exponents, the appearance is the powers are added together. 3 plus 5 is 8. 7 plus 12 is 19. So if I have y to the 11th times y to the 23rd, that's going to give me y to the 34th. If I have z to the 5th times z to the 9th, that's going to give me z to the 14th. Good. If I have x to the 12th times y to the 5th, that's going to give me... Can't combine them, different bases. This adding the powers only works if I have the same base here. These are both 10s, so I can add the powers. These are both y's, so I can add the powers. These are both z's. If I have different bases, I can't combine the powers. I can still multiply them and get x to the 12th, y to the 5th, but I cannot combine the powers. So 10 to the 7th times 10 to the negative third is 10 to the 4th. 7 plus a negative 3. Here's 0, there's 7. Negative 3 ends up at 4. 10 to the negative 8th times 10 to the 10th is 10 to the 2nd. Negative 8, positive 10, ends up at 2. 10 to the negative third times 10 to the negative 5th is 10 to the negative 8. Yeah, negative 3, negative 5. Both go negative, so it's negative 8. Well, 10 to the 9th times 10 to the negative 5th is 10 to the 4th. 9, negative 5, ends up at 4. 10 to the 3rd times 10 to the negative 6th is negative 3. Very good. 3, negative 6, ends up at negative 3. Any questions so far? Okay, well, what if I do this? 10 to the 5th divided by 10 to the 3rd. Now, I could have wrote it like this, but writing it in fraction form, it's still a division problem, but it allows me to work with it a little bit easier. 10 to the 5th is still 5 tens multiplied together. 10 to the 3rd is 3 tens multiplied together. In a fraction, remember we can divide out top and bottom. We can divide the same number into both the top and bottom. So I'm going to divide out a 10. It's gone. Can I divide out another 10? Sure can. Another one? Yes. What's left? 2 tens. 10 to the 2nd. If I had 10 to the 9th divided by 10 to the 5th, what am I going to get? 10 to the 4th. You see a pattern developing here? 5, when I'm dividing exponents with the same base, the appearance is that the powers are subtracted. 5 minus 3 is 2. 9 minus 5 is 4. So if I have 10 to the 12th divided by 10 to the 5th, I'm going to get 10 to the 7th. 12 minus 5 is 7. So 10 to the 25th divided by 10 to the 6th is 10 to the 19th. 25 minus 6 is 19. 10 to the 8th divided by 10 to the 2nd is 10 to the 6th. 10 to the 34th divided by 10 to the 25th is 10 to the 9th. 34 minus 25 is 9. You get confused yet? You okay over there?
No, I'm fine.
You got her? Okay, well, how about this one? Well, 9 minus a negative 4 is 9 plus 4, or 13. 10 to the 13th.
I completely had that.
10 to the negative 5th divided by 10 to the 7th.
That would be
Negative 5 minus 7 is negative 5 plus, hey Tyler, wait till I actually ask the question, bud. Negative 5 plus a negative 7 would be negative 12. So that's 10 to the negative 12. So if I have 10 to the negative 5th divided by 10 to the negative 12th, what do I get? So it's negative 5 minus a negative 12. That's going to become negative 5 plus positive 12. So here's 0. Negative 5, positive 12 is going to be at positive 7. This is where the negative powers really screw us up, because we're subtracting. When we divide, we're subtracting the powers. So it can be really strange. 10 to the 3rd divided by 10 to the negative 7th is going to give us what? 3 minus a negative 7 is 3 plus 7, or 10. Ten to the negative 5th divided by 10 to the 8th is negative 5 minus 8 becomes negative 5 plus negative 8. Negative 5, negative 8 is negative 13. I'm seeing some blank looks. Did I lose you? It's just remembering how to do the subtraction with your integers and your negatives. What's that? Yeah, this is getting recorded, yeah. This might be one you watch a time or two? Okay. Pop some popcorn, invite some friends over. If you charge admission, I get half, just so you know. What's that going to be? Am I adding or subtracting? I'm adding because I'm multiplying.
10 to the power of 2.
5 plus negative 8. Here's positive 5, negative 8. So it's going to be a negative 3. Difference between 5 and 8 is 3. So I have 10 to the negative 7th times 10 to the 4th over 10 to the 9th. So I'm going to have to go a couple of steps this time. First of all, this is a fraction bar, which means I have to do everything on top first. What is 10 to the negative 7th times 10 to the 4th? 10 to the negative 3, yeah, over 10 to the 9th. So now it's 10 to the negative 3 divided by 10 to the 9th. Negative 3 minus 9 is negative 3 plus negative 9, or 10 to the negative 12. Yep, when you multiply, you're adding the powers. So negative 7 plus 4 is negative 3. And when you're dividing, you're subtracting. So negative 3 minus 9 is negative 12. It does get tricky because the division, especially with the subtraction, is tough with the negatives. You got to make sure. I have to write it out like this, or I start to get confused when I'm subtracting the negatives. I have to change it to addition in order to keep it straight. So 10 to the 8th times 10 to the negative 3rd over 10 to the negative 5th times 10 to the 11th. Now there's a fraction bar here, which means I have to do everything on top first, then everything on bottom, then I can divide. On top, what do I get? I'm multiplying, so I'm going to do what to the powers? Add them. So 8 plus negative 3 is 5. Positive 8, negative 3 is going to end up with 5. On bottom, I get, I'm multiplying, so I'm still adding powers at negative 5, positive 11, so that's going to be a positive 6. Now I divide 10 to the 5th, divided by 10 to the 6th. What's 5 minus 6?
1.
Negative 1. 10 to the negative 1. I'm seeing some unhappy looks out there. I'm going to have you try one in your notes. Try that one quick, see what you come up with. Okay, so on top, 10 to the negative 7th times 10 to the 5th is 10 to the... Are we adding or subtracting there? Adding. We're multiplying, so we add powers. Negative 7 plus 5 is negative 2. On bottom, 10 to the 8th times 10 to the negative 13th is negative 5. Good. We're still multiplying, so we add the powers. Now, we're dividing. 10 to the negative 2 divided by 10 to the negative 5. It'll be negative 2 minus a negative 5, which becomes negative 2 plus 5. So negative 2 plus 5 is 3. 10 to the 3rd. How many of you had 10 to the 3rd? How many have no idea how I got 10 to the 3rd? Want to try one more? See how you do? Try that one, see how it goes. So, of course, on top, that's just going to be 10 to the negative 7th for now. There is nothing to do there. On bottom, we get 10 to the power of Negative 3, good. We're multiplying, so we're going to add the powers. 5 plus negative 8 is negative 3. So now we're going to divide here. When we divide, we subtract the powers. So it's negative 7 minus a negative 3. Or negative 7 plus 3. So negative 7 plus 3 is negative 4. 10 to the negative 4. How many of you had that? A few more this time? Okay. Well, what if I do this? I have 10 to the 4th to the power of 3. That's saying 10 to the 4th times 10 to the 4th times 10 to the 4th. Well, we already know how to do 10 to the 4th times 10 to the 4th. What do we get? 4 plus 4 is 8, right? 10 to the 8th. Now we're going to multiply by another 10 to the 4th, which will be 10 to the 12th. There you go. That's exactly it. 4 times 3 makes 12. So 10 to the 7th to the power of 5 is going to be 10 to the 35. Good. 10 to the 9th to the power of 4 is going to be 10 to the 9 times 4 is 36. What's that?
10 to the negative 7 times negative 5.
Sure. Actually do this. 10 to the negative 7 to the power of 5. That's going to be 10 to the negative 7 times 5 is negative 35. Or we could have 10 to the 4th to the negative 8th. 4 times negative 8 is negative 32. Excuse me. Or 10 to the negative 6th to the power of negative 3. Now a negative times a negative is positive. So 6 times 3 is 18. So that's 10 to the positive 18. So 10 to the 5th to the negative 6 is 10 to the 5 times 6 is 30. So it's a negative 30. Well, let's make this interesting. So obviously we have to do what's inside the parentheses first. What is 10 to the 4th times 10 to the negative 11th? Are we adding or subtracting those powers? We're multiplying, so we add the powers. So 4 plus negative 11 is negative 7. 10 to the negative 7. Now it's still to the power, I don't know where that 4 came from there. It should be a 3. To the power of 3 out there. So now what do we do with those powers? A power to another power, we multiply them. So negative times a positive is a negative. 7 times 3 is 21. So it's, oh, sure. Yeah, you got to add those because we're multiplying, and then multiply by the power. Let's try another one. It takes a while to get used to it because you're multiplying. You think you should be multiplying, and well, you are multiplying, but you're adding the powers.
Would that be the same? Yeah.
Yeah. So let's do something like this. Again, we do what's in the parentheses first. What's 10 to the 7th times 10 to the negative 4th? What's 7 plus a negative 4, which is positive 3. And now 10 to the 3rd to the negative 5th. 3 times negative 5 is negative 15. 10 to the negative 15. So here we got to do the division first. Inside the parentheses we get 10 to the We're dividing, so we're going to subtract powers. 4 minus 9 is negative 5. And now to the third power, or negative third power, we're multiplying 15. Good. Negative times negative is positive. 5 times 3 is 15. So that's 10 to the 15th. How about this one? Well, there might be a couple of steps to go through here. First, on top, 10 to the 4th times 10 to the negative 9th will be 10 to the... We're multiplying, so we're going to add the powers. 4 plus negative 9 is negative 5. 10 to the negative 3 on bottom, there's nothing else to do with it. Then we can divide. 10 to the negative 5th divided by 10 to the negative 3. That'll be negative 5 minus a negative 3. Or negative 5 plus 3, which is negative 2. Then to the power of 7, negative 14. Try that one in your notes quick. See how it comes out. So first thing we're going to do, we're going to do the top and we're going to do the bottom. On top, 10 to the 8th times 10, or 10 to the negative 8th times 10 to the 5th. Negative 8 plus 5 is negative 3. On bottom, 10 to the 3rd times 10 to the negative 11th is 3 plus negative 11 is negative 8. Now we're going to divide. 10 to the negative 3rd divided by 10 to the negative 8. Negative 3 minus negative 8 is negative 3 plus 8, or positive 5. Then 10 to the 5th to the power of negative 4 is 10 to the negative 20. These will take a little while to get used to. Why do we care? Why is it that these are important? Well, let's take a look. There is something that ties this together a little bit. And I said at the beginning, those powers of 10 were going to come back to be useful to us. Going back to our first couple days of class, we had our place values. This is ones, tens, hundreds, 1,000s, 10,000s, 100,000s, 1 million, and so on. This is the 1/10ths, 100ths, 1,000ths, 10,000ths, and so on. If we look at those values, they look awful familiar to that list we made of our powers of 10 earlier. 1 is 10 to the power of 0. 10 is 10 to the 1. It's 10 to the 2nd. 10 to the 3rd. 10 to the 4th. 10 to the 5th. A million is 10 to the 6th. 10 million would be 10 to the 7th. 100 million, 10 to the 8th. 1 over 10 was 10 to the negative 1. 1/100th was 10 to the negative 2, and so on. Our number system is what we call a decimal number system, or base 10, which means that our numbers, the place values, are powers of 10. If you got into computer programming, you would look at octal number systems, where your place values are actually powers of 8, or binary number systems, where the place values are powers of 2. So anyway, we like to abbreviate our numbers. Let's say we have 5,800,000. We would sometimes abbreviate that as 5.8 million. But now that we know our powers of 10, we can actually, instead of writing out the word million, we could write it as 5.8 times 10 to the 6th, which means million. This, of course, is or scientific notation. We can do on the other side, same on the other side. We have 0.0029. That can be written as 2.9, and the 2 is in the 10 to the negative 3 place value. So times 10 to the negative 3. Now, we don't really want to write out this number line every time we convert a number into scientific notation. So there's got to be a shortcut, and we've all seen it. Let's look at our 5.8 million. 5,800,000. Where is the decimal point in that right now? Well, it's not written, so that means it's at the end, right here. When we put numbers in scientific notation, though, we only want to have one digit in front of the decimal point, and it cannot be a 0. So we want the decimal point to be here, 5.8. How many places does it have to move? 1, 2, 3, 4, 5, 6. Hence, 10 to the 6th. The decimal moves 6 places. So if we had 0.000083, right now the decimal point's here. We want it to be where? Well, we want one digit in front of the decimal point, and it can't be a 0, so it has to go here. It has to move 1, 2, 3, 4, 5, 6. This is going to be 8.3 times 10 to the not 6, but negative 6. How did we know that one had to be negative? Because this is a really small number. It's less than 1. So it has to be in the negative place values. This had to be a positive 6 because it's a large number. It's in the positive place values. So if I'm going to convert 410,000 in scientific notation, it'll be 4.1 because I want one digit in front of the decimal point. How many spots does the decimal point have to move? Well, starting here, it goes 1, 2, 3, 4, 5. So times 10 to the, is it 5 or negative 5? It's 5. That was a big number, so it's a positive place value. Yeah. So here, we want this to be 8.9, so we have our one digit in front of the decimal point. So decimal point starting here, and we're moving to here. It's going 1, 2, 3, 4 spots. And we know it's negative 4 because it's a really small number. So what's this is going to become? 9.5. Now this negative up front does not affect the decimal point at all, but it makes this a negative 9.5 instead of a positive 9.5. It does not affect my power on the 10 at all either. My decimal point is right here, and I want it to be here. It's got to move 1, 2, 3, 4, 5, 6, 7. It's a small number, so it's negative 7.
That sounds like a large number. Hard to tell which one's like large and which one's
So I have negative 25 million.
that's gonna be
It's going to be negative 2.5. Again, the negative is just in front of the 2.5. Doesn't affect our place values or decimal points or anything else. Times 10 to the, right now the decimal point's here and we want it here. It has to move 1, 2, 3, 4, 5, 6, 7 spots. Negative or positive?
positive.
Positive, because this is a big number. It's bigger than 1, so it's in the positive place values. So, last thing we need to do is going the other direction. If I want to convert that from scientific notation back into standard notation, is this, first of all, is this going to be a small or a large number? It's 10 to the negative 4, so it's going to be small. The 4 tells me the decimal point has to go 4 spots. But since it's going to be a small number, I have to make it smaller. So I have to move the decimal point in this direction. So that's 1 spot. To move 2 spots, I have to add a 0. So there's 2. Add another 0. 3. Add another 0. 4. So this is 0.00058. Or if I had 2.9 times 10 to the 8th, this one is going to be a large number because it's positive 8. So after my decimal point 8 spots, I go 1. To move it again, I got to add zeros. So 2, 3, 4, 5, 6, 7, 8. 290 million is what I get. Any questions? Okay, well, in your book, there are several pages that go over this. On page 121, it's exercise 2.4, problems 1 through 45, the odds. On page 125, exercise 2.5, problems 1 through 29, the odds. On page 130, exercise 2.6, problems 1 through 57, the odds. Now I realize there's a lot of problems here, and as always, do a few of the easy ones, skip ahead if you're doing well on them. This first page here is dealing with the fractions. Now, have I showed you guys how to use the fraction function on your calculator? The ABC key? Most of you have an ABC key on your calculator, or an ND key, depending on which version of the calculator you have. So if I have a negative 5/8 plus 1/6, to punch that in the calculator, the negative, of course, is not the subtraction key. It's down by your equal sign. There's a key that looks like this, negative. So you'd press that key, then do 5, ABC 8, that's negative 5/8, plus 1, ABC 6, that puts in the positive 1/6. That should then spit out for you, what, negative 15, positive 4, and negative 11 24ths. At this point, now that we've done fractions, we've had our test on it, it's okay to start using the calculator for the fractions. If you have problems getting the calculator to work, let me know, and I'll go over it with you so you get that figured out. Does everybody have those pages down?